Welcome to qnawire.
Okay, so we know the position versus time function is given at 0.20 meter sine 2 pi over 2 second t. So we know the amplitude should be equal to 0.20 meter and the time period should be 2.0 seconds. So this is the position versus time graph, okay? And as you can tell, the car is at equilibrium position when the time is equal to 0 second, 1 second, and 2 seconds. And at equilibrium position, the velocity is at maximum level, okay? And the potential energy at points should be equal to 0 since there's no displacement there. So therefore, let's determine the spring constant. So if a spring constant K is equal to m times omega squared, m is the mass, omega is the angular frequency. So eventually we have spring constant is equal to 19.74 Newton per meter. And then we can determine total energy of the system, which is 1/2 Ka squared, which is about 0.395 Joule. So now we can construct the energy bar charts for the motion. So when time is equal to 0, if we take a look at the position versus time graph, at time equals 0, the displacement is 0, okay, which means that potential energy is 0. So all the total energy becomes kinetic energy, okay, which should look something like this. So potential energy is 0, and kinetic energy is here. And the kinetic energy at this point is become the total energy of the system. So therefore, kinetic energy should be equal to 0.395 Joule. And when time become 1/4 of the time period, which is 0.5 seconds, if you take a look at the graph at 0.5 seconds, the displacement becomes a maximum, which means that it's at amplitude points. Okay, so therefore the potential energy is equal to the total energy of the system. So therefore we have such graph here. And at this point, the potential energy is equal to 0.395 Joule, since it's equal to the total energy of the system. And that time equal to 1/2 a period, which is 1 second. If we take a look at the position versus time graph, it's at equilibrium position again. So therefore, its potential energy should be 0, but its kinetic energy should be equal to the total energy of the system. So it looks exactly like the first graph I drew. So the kinetic energy is equal to 0.395 Joule. And now let's look at when the time equal to 3/4 of the time period, which is 1.5 seconds. So at 1.5 seconds, the displacements become the maximum displacement again, okay? So therefore, the potential energy at this point is equal to the total energy of the system, and kinetic energy is equal to 0. So therefore, it should look something like this. Oop. Oh, sorry about that. Okay, so it should look something like this. And now let's take a look at when the time is equal to the period, which is the 2 seconds. So if we take a look at the position versus time graph, at 2 seconds, the car is back into equilibrium position again. So therefore, the potential energy is equal to 0, but the kinetic energy is equal to the total energy of the system. So we should have some graph like this. And the kinetic energy is equal to 0.395 joule. And this is my answer for this question.